Hello everyone, welcome to Prajim Technologies. My name is Avish and this is part 8 of the design patterns tutorial. In this session, we will discuss what is factory design pattern, implementation guidelines of factory design pattern, and we'll take a look at an example to implement simple factory. Please refer to the previous parts of this tutorial before proceeding. Now let's understand what is factory design pattern. As mentioned in the first part of the tutorial, factory method pattern belongs to creational type patterns. Factory pattern is one of the most used design patterns in real-world applications. As per the Gang of Four definition, in factory pattern, we define an interface for creating an object, but let subclasses decide which class to instantiate, which means the factory method lets a class defer instantiation it uses to its subclasses. From the above definition, we can state that factory pattern creates object without exposing the creation logic to the client and refer to the newly created object using a common interface. Now, if you take a look at the diagram below, the client is an object that requires an instance of another object. Let's say it requires the product object for some purpose. Rather than creating the product object instance directly, the client delegates this responsibility to the factory. Once invoked, the factory creates a new instance of the product, passing it back to the client. To simplify this, we can say that the client uses the factory to create an instance of the product. Now, let's take a look at the implementation guidelines. The first thing which goes in our mind is when to use this pattern. We need to choose factory pattern when the object need to be extended to subclasses. The classes doesn't know what exact subclasses it has to create, and the product implementation tend to change over time and client remains unchanged. These are some of the scenarios where we need to choose factory design pattern. If this is confusing at this moment, don't worry. We are going to take a deep dive on implementing these points using a simple example. Now let's switch to Visual Studio and learn how we can create a simple factory. To make the things faster, let's work on the example that we have used in the previous session of singleton design pattern. To proceed further, we strongly recommend you to refer to the singleton design pattern tutorials which demonstrate on how we have created this portal solution. Now if you recap the earlier session, we have used this portal to perform CRUD operations on the employee. Now let's imagine a situation where we have a business requirement which states that we need to differentiate employees as permanent and contract and segregate their pay scales as well as bonus on their employee types. You might be wondering how this requirement is related to factory design pattern. To answer that, first let's implement this requirement without using factory design pattern. Let's switch to Visual Studio. Our first step is to update the employee portal database. Let's expand app data, right click on employee portal. Let's open the database and look at that. There is only one employee table. Let's add another master table which is employee underscore type, and let's add a column called employee type which is of varchar 150, and let's remove allow nulls here. Let's also change this identity column as identity specification to true, and let's update the table to the database. Let's right click on the tables and refresh the tables. Look at that, employee underscore type table is added to the employee portal DB. Let's show the table data. Let's add employee type as permanent and contract. Our next step is to update the employee table. Before that, let's clean up the existing data in the employee table. Right click on the employee table, new query, and let's say truncate table employee. Let's run the script. Let's now add new columns that are required to address the business requirement. Let's open the table definition. Let's add hourly pay, which is of decimal, and bonus in percentage. Let's also choose decimal for this, and let's add an employee type ID, which is a foreign key reference to the employee type table. Let's right click on the foreign keys and add new foreign key. Let's change this to table to employee type, employee underscore type. Let's also change the script over here in the T-SQL foreign key column name as employee type ID, which references to table. In our case it will be employee underscore type table, and the table column will be ID column. Let's update these changes to the database. Now that the database changes are complete, let's now switch to the Visual Studio solution and let's inspect the models, and let's open the employee model.edmx file. Look at that, the employee model.edmx is not refreshed yet with the latest changes. Let's update this EDMX file with the latest schema changes. How do we do that? Right click on this EDMX file and choose update model from database, and let's add tables which are employee type, which is a new table which we have added, and let's click on finish. Look at that, the employee model is updated with the latest changes. Now that we are done updating the portal database and its corresponding models, the next step is to update the employees controller. Let's switch to the employees controller. Now if you inspect this code and recollect the previous session of Singleton design pattern, we have added this custom exception handling in this controller. Let's move this code to a new controller. Right click on the controllers and let's click on add controller. Let's choose MVC5 empty controller, click on add, and let's name this as base controller. Let's remove the existing code and let's move this onException method to this base controller. Let's create a constructor public base controller. Let's switch back to the employees controller and move the ilog related code to this base controller. Let's resolve this error using logger. You may be wondering why we need to move this code to base controller. The idea of moving the code is to inherit the base controller to the rest of the controllers so that all the exceptions can be handled at one place, and any model related refresh updates in the controllers will not impact the auto-generated code of the controllers. Let's now proceed with the step of updating the employees controller. Right click on the controllers, click on add controller, and choose the third option, which is MVC5 controller with views using entity framework. Click on add. Let's choose the model class as employee, and let's change the controller name from employees1 controller to employees controller so that we are overwriting the existing employees controller. Click on add. It prompts to update the employees controller. Let's proceed with yes. The employees controller is updated. Let's switch to the employees controller and inspect the same. Look at that. The changes are updated in the employees controller. Let's inherit the controller with base controller so that all the exceptions related to the employees controller are passed through the base controller and are logged through the onException method. Let's now switch to the views, expand employees, and let's inspect the create view. And notice that the hourly pay and bonus are updated in the create view as well, and the rest of the views are updated with the latest changes. Let's switch back to the employees controller and let's compute the bonus and hourly pay before creating the employee. Let's assume that for a permanent employee, the hourly pay is $8 and the bonus is 10%, whereas for contract employee, the hourly pay is $12 with a 5% bonus. Let's compute that before creating the employee. Let's say if employee dot employee type ID equal to 1, which corresponds to a permanent employee. Now let's say the employee dot hourly pay equal to $8, whereas employee dot bonus equal to 10%. Else if employee dot employee type ID equal to 2, which means he's a contract employee, let's change the hourly pay as employee dot hourly pay equal to $12, whereas the employee's bonus will remain at 5%. Now that we are computing the hourly pay and bonus in the controller, let's remove the ability of entering them in the create view. Let's comment out the bonus and hourly pay entries in the create view. Let's run this application. Let's click on employees tab. Let's create a new employee. Let's name the employee as John. Job description as manager. And let's give his number as A1234. Department as IT. Let's choose the employee type as permanent and let's click create. Let's create another employee. Let's name the employee as Smith. Let's give the job description as contract dev. Let's give the number as C1234. Let's give his department as IT. Let's change his employee type as contract. Let's click create. Look at that. Both John and Smith are created with their respective hourly and bonus pays. Let's stop this application and switch back to the employee controller. Now if you inspect this code, we have achieved our requirement of computing the bonus and hourly pay based on the employee types. But we have introduced few drawbacks with this coding standards. The first thing is that we have introduced a tightly coupled business logic within the employee controller. If you are wondering how, let's take an example, or let's imagine a situation where we need to add another employee type. Let's call it as a temporary employee. To accommodate another employee type, we end up updating the employee controller every time, which is only meant to perform user interactions. Further, changing the code in this manner will introduce more maintenance efforts both in development and testing process, and this approach is error prone. To address this, let's see how we can simplify and decouple this logic. To decouple this logic, we need to create two methods which computes bonus and hourly pay. Let's right click on this web, add a new folder, and let's call this folder as managers, which manages the business logic. Let's right click on this, add new item. Let's create an interface so that we declare those two methods in this interface. Let's name this interface as iEmployee Manager. Let's change this interface to public, and let's create two methods with decimal as return type, and let's call it as getBonus, and let's create another method called getPay. These interface methods are supposed to be consumed in the respective permanent and contract employee managers. Let's create those two managers. Right click on the managers folder, add new item. Let's choose the class and let's name this class as permanent employee manager, and let's inherit iEmployee Manager here. Implement interface. Let's return the bonus as 10% and let's return the pay as $8. Let's now add another manager, add new item. Let's add a class and name it as contract employee manager. Let's do the same thing. Let's inherit iEmployee Manager interface implement the interface, and let's return the bonus as 5%, and let's return the pay as $12 per hour. 12. Now, depending on the employee type, we need to create the instance of the respective manager classes and return them back to the controller, which means the employees controller need to decouple this code and delegate the creation or production of respective manager classes to a mediator. Since the mediator is producing or instantiating those classes, let's refer to that mediator as a factory. Let's right click on the portal and add new folder, and let's call this folder as factory, and let's right click and add new item, choose a class, and let's create a employee manager factory. Now let's create a method called public iEmployeeManager, which returns an iEmployeeManager, and name this method as getEmployeeManager. This employee manager will accept input as employee type ID and returns back that respective, depending on the employee type ID, it returns back the respective manager classes. Let's declare iEmployeeManager, which is the return value. Let's assign this to null. Let's first resolve these issues using web.managers, and let's say if employee type ID equal to 1, then let's assign the return value equal to new permanent employee manager. Else, if employee type ID equal to 2, let's return the return value, let's assign the return value equal to new contract employee manager. Let's return the return value at the end. For our convenience, we have used the if statement. Another alternative is to replace the if statement with switch case and use an employee type enum or employee type ID as switch selection. Now if we need to add another employee type, for example, if we need to add a temporary employee, then we need to enhance this logic by creating a new temporary employee manager class similar to that of permanent and contract employee managers, and then we create the instance of the temporary employee manager in this factory similar to these instantiations. Now that we have created the employee manager factory to handle the respective employee managers, let's see how we can consume these changes in the employees controller. Let's switch to employees controller. If you look at this code in this employee controller, the logic is tightly coupled with the employee types. Let's decouple it and chain this with the already implemented factory. Let's remove this logic and replace it with employee manager factory using web factory. Let's say emp factory equal to new employee manager factory. Now iEmployee manager equal to, let's resolve this iEmployee manager first by using web.managers, equal to employee factory dot get employee manager. Look at that, it accepts employee type ID as the input parameter. Let's say employee dot employee type ID. Now let's use this employee manager and employee manager dot get bonus will returns the respective bonus of that manager. Let's assign this bonus to employee dot bonus equal to employee manager dot bonus. Let's say employee dot hourly pay equal to employee manager dot get pay. Let's run this application. Let's click on Employees tab. Create a new employee. Let's name the employee as Jason and the job description as developer. Let's input the number as P3456 and the department as IT. Let's click create. Look at that. The new employee is successfully created, aligning to the business rules of permanent employee type. Let's create another employee. Let's name the employee as Williams and the job description as contract HR. Let's input the number as C4578, department as HR. Let's choose the employee type as contract and click create. Notice that we have successfully added 2 new employees with a simple factory implementation. With this, we have successfully deferred the instance creation by implementing a simple factory with the mentioned guidelines in the beginning of this session. Any changes to the employee type will be successfully addressed at the factory and its manager classes, and the controller is not impacted with these changes. Now let's switch to another diagram. From the illustrated diagram, the client, which is the employee controller in our case, uses the factory, which is the employee manager factory, and creates the respective products, which in our case are contract and permanent employee manager, through the interface iEmployee Manager. Hence we can say that we have achieved a simple factory implementation. In the next session, we will discuss how we can enhance the simple factory to a factory method pattern. Till then, thank you for listening and have a great day.